Imagine you've written a Python program, a simple one, running inside a for loop. You hit run, and then, you wait. Each task finishes, slowly, one after another, like watching paint dry. What if I told you there's a way to do them all at once, using the full power of your CPU? Now we're talking speed. The issue is this: when you use a normal for loop, your code runs sequentially, line by line, task by task. Even if your computer has multiple cores, Python by default is using just one, the rest? Sitting there bored. It's like having a team of workers, but asking just one to do the entire job while the others take a nap. Now imagine assigning every worker their own task, and doing everything in parallel. That's what multiprocessing does. Python's built-in multiprocessing module lets you run multiple tasks simultaneously, using separate processes on each CPU core. Instead of waiting for each job to finish one by one, you finish all of them together. Fast, efficient, clean. And the best part? It's easy to implement, and I'm about to show you how. Create a Python file. First, we import the OS module. This lets us interact with the operating system, like creating folders. Next, we import time to help us measure how long the whole process takes. Request is used to download content from the internet. In this case, we'll be fetching some files from a URL. This line creates a folder named images. If it already exists, Python won't throw an error. Here's our function. Download_file takes a URL and a file name number. It sends a GET request to that URL and stores the response. Then, it opens a new file in write binary mode inside the images folder and names it using the number we passed. And finally, it writes the downloaded content to that file. Here's the sample URL we're downloading from. It's a placeholder image site. You can replace this with anything. I'm increasing the size to test download speed with a larger file. Now we record the start time, just before the downloads begin. This loop runs 20 times, one for each file we want to download. Before each download, we print which file is starting. Then we call our function and start downloading that file. And once done, we print that the file is finished downloading. After the loop finishes, we record the end time. Finally, we calculate and print the total time it took, formatted to 2 decimal places. Then we hit the run button.
Huh?
Now create a new Python file. First, we import the necessary modules: OS for working with folders, time to track how long everything takes, requests to download data from the internet, and multiprocessing to run tasks in parallel. This line creates a folder if it doesn't already exist. It's where our downloaded files will be saved. This function takes a URL and a name and handles downloading the file. Right when the download begins, we print a message saying which file has started. We wrap the download in a try block to handle errors, just in case something fails. We send a GET request to the URL and store the response. We open a new file in binary write mode and name it using the number passed in. We write the content we downloaded into that file. Once the file is saved, we print that the download is complete. If something goes wrong during the download, this catches the error. And prints an error message so we know which file failed. This line ensures that multiprocessing runs safely when we start the script. It's required for Windows and good practice in general. Now we record the start time, so we can calculate total duration later. This is the URL we're using to test. It gives us a big image to simulate a real download task. We loop 20 times, one for each download. Inside the loop, we create a new process that will run our download file function with the current number. Then we start that process, and it begins downloading in the background. We add that process to our list so we can keep track of it. We create an empty list called pros to keep track of all the processes we start. After starting all processes, we loop through them again. And use join to wait for each one to finish. This makes sure we don't end the script early. Once all downloads are done, we record the end time. Finally, we print how long the entire process took. Execute the Python file. This is the magic of multiprocessing, more speed, less waste. Efficient, powerful, and super useful for time-consuming tasks in Python.